Obviously, if something is supervised, there has to be something which is unsupervised, right? So let's look at one example, or in fact, we'll use the same example where imagine that you did not have the categorization whether those particular patients were malignant or benign. Let's say you did not have that information, right? But let's say you want to make a determination that, oh, you know what, so maybe some patients should be actually going into the ICU, or some patients could be going into the regular bed, or maybe you can do an outpatient, right? Or it could be another scenario where let's say you're in marketing or HR or finance, you want to make let's say you're marketing and you want to give a customized offering of your service, and some customers may have different profile and other customers may have different profile. So it would help if you could club them together so that you can provide customized offering to those customers, right? So this technique is called unsupervised machine learning. In this case, there is no training provided. The model figures out on itself. Okay, and how does it do that? All it simply does is it simply minimizes the intra-cluster distance, meaning it tries to, let's say, so each dot is a patient, and this is a cluster or a group, and it tries to minimize the number of patients, that average distance between patients, and it tries to maximize the distance between different clusters. So this is the technique that is used for unsupervised machine learning, minimizes average distance within the cluster and maximizes distance between clusters. So I'll just give a quick demonstration for that. So we'll use the same breast cancer data example. And then again, there are different models. There's one called K-means, which sounds like KNN, but it's really not, it's different. I like this particular one called DB-scan. And then it'll create those clusters where now you can see that these patients were grouped differently, some of them in blue, some of them in yellow and green. Again, I'm displaying in 2 dimensions, but this split is being done in multi-dimension by the software automatically based on what features we use. Okay, so this is how unsupervised machine learning works. Remember, I didn't provide any training. I just said, go figure it out, and it created those clusters for us. So now we can figure out that, hey, these patients, there's something unique about them. Maybe they need to be treated in the ICU or something. Okay, I'm just making up stuff to make the point, but I hope this is clear. Okay, so again, there are different models, and this helps us visualize what's going on, and you can compare different tools, different variables, and you can see how the grouping is done. So this was an example of unsupervised machine learning model. There are other techniques called semi-supervised. There's reinforcement learning. In semi-supervised, you kind of, obviously, as the name suggests, you kind of do a hybrid of supervised and unsupervised. You start with a small label data or small training set, and then you kind of improve the model using a combination of unsupervised and unsupervised. In reinforcement learning, it is learning from how humans, most of these games, like when these games beat chess champions or the AlphaGo champions, they use this technique called reinforcement learning, where the training is actually based on this, is like how humans learn, right? So when we are kids and when you're trying to learn to walk, every time we fall down, we learn that, oh, I should not be, stepping awkwardly, or I'm going to fall. So every time we fall, we learn, right? And I'm not being, philosophical here. Literally, that's how we learn, right? So the model kind of does something, right? If you're training it to play a game, every time it wins, it takes certain actions to maximize rewards. If it is losing, it does not take those actions. So that's how reinforcement learning works. So these are the different categories of machine learning. So supervised, unsupervised. Oh, I forgot to mention, these are different categories: density-based scans, hierarchical clustering, partition-based clustering. These are the different categories of unsupervised machine learning. So hopefully that gives you a big picture of what the main 2 ideas is what I was wanted to present. So if you're in management, if you're serious, you definitely need to know this high-level difference between supervised and unsupervised machine learning. And then now, if you're serious about getting into this field of AI and machine learning, you should definitely know the next topic, which is deep learning or artificial neural network.